Hello to all. My name is Mikhail Chernoskutov. I work both for education and academia, and my talk today is about high-performance graph processing. This research was inspired by recent works of Olaf Sporns, this guy who developed the term human connectome. His research group looks at the brain like a big graph where neurons are particular vertices and they have some connections between it. A graph like human brain is a big. It have trillions of nodes and trillions of edges between these nodes. So my main research topic is high-performance graph processing. So I'm a guy from supercomputer research, but our research topic has a lot of the same things. That's why I'm here and trying to share my ideas with human brain researchers. Maybe it will be useful. So, nevertheless, imagine that we need to traverse to do some graph algorithms on big graph, which distributed on the memory of many nodes. It's, for instance, 1 trillion of nodes and 100 trillions of edges. And the interesting things that when we trying to traverse big graphs, parallel implementation may be sequential implementation may outperform its parallel counterpart. Why it's happened? It's happened due to a couple of big problems. One is workload imbalance. So imagine a graph with cubed degree distribution. So we have nodes with 1 million of edges and nodes with 100 of edges. So there is a big imbalance when some computational threads processing the nodes with a high number of edges and all other computational threads. So I developed a method which helps to make processing of heavyweight vertices distributed amongst multiple threads and make processing of lightweight vertices are fused in a single thread. The next big problem is a high amount of data transfer between computational processes. So we're trying to solve this problem by combining two types of graph traversal. It's a top-down approach. It's, I think all of you are known what is it. And bottom-up approach, which developed rather recently in it's a few years ago. And combining these two approaches, we can dramatically reduce the amount of data transfer between different processes. So what results I have? You can see the plot, and the higher it's the better. So I implement my algorithm on the supercomputer in our institution in 8 nodes of this supercomputer, and I receive the speed up more than 5 times. So it was processed a graph with trillions of edges. It's not so big like brain, but it seems to be like this. Okay, thanks for listening, and don't hesitate to ask me questions on poster session. Thank you.